What if I told you there's a new AI that can tackle complex tasks 4.5 times faster than the giants we all know? We're talking about a model that doesn't just work harder, it works smarter, deploying an entire team of AI agents at once. This thing is sending shockwaves through the industry. We're talking about Kimi K2.5. Okay, let's dive in. But before we do, make sure you hit that like button, comment your thoughts below, and subscribe to @BrandTechAuth for more deep dives into the future of AI.
So yeah, this is the number that is absolutely shaking up the AI world right now. 4.5 times. I mean, that's a seriously bold claim, right? It suggests a massive, massive leap in just how efficient these things can be. We're talking about executing really complex tasks way, way faster than even the most powerful single AI agents out there, working all by themselves.
And here it is. This is the new challenger, coming from a company called Moonshot AI. And get this, it's a 1 trillion parameter open weight model. But look, this is not just some simple upgrade. It's not Kimi 2.0. No, this is a fundamental rethink of how AI actually gets work done. It's built on an architecture that, honestly, could completely change the game.
All right, so what is this new speed demon? And more importantly, how in the world does it pull off this incredible performance leap? Let's get under the hood and really break down what makes this thing tick.
Okay, the key phrase you need to remember here is native multimodal. Now, what does that mean? Well, unlike a lot of other models where, vision capabilities are kind of bolted on as an afterthought, Kimi K2.5 was built from the ground up, from day one, to understand both images and text seamlessly. It's in its DNA. But that's not its real secret weapon. The source of all that incredible speed, well, that's something else entirely.
So what is that secret weapon? Well, it's a completely new way of thinking about how an AI solves problems. It's a whole new paradigm, and they're calling it the agent swarm. Yeah, this is the magic behind the curtain. It's a training method called parallel agent reinforcement learning, or PARL. So instead of having just one AI plugging away at tasks one by one by one, PARL trains a master orchestrator AI. This orchestrator looks at a really complex problem, and then, on the fly, it creates a whole team of specialist sub-agents to tackle all the different parts of the problem at the same time, in parallel.
You know, the old way, the traditional way, an AI agent works sequentially. Just think of it like one person on an assembly line, right? They pick up the task, they use tool number 1, then they use tool number 2, then tool number 3, and eventually they get a result. I mean, it works, it's effective, but it is just inherently slow because everything has to happen in a specific order.
But Kimi's agent swarm, it completely flips that script on its head. That orchestrator we talked about, it acts like a super efficient project manager. It takes the main task, breaks it down into all these smaller pieces, and then assigns them to a bunch of different sub-agents who all work at the same time. And it's this parallel approach that just drastically cuts down the time it takes to get to that final result.
And this table just illustrates the difference perfectly. Look, we are moving away from having predefined agents in some handcrafted, rigid workflow to a dynamic, self-directed system. Kimi can literally spin up to 100 agents on the fly and coordinate 1,500 tool calls at once. That's insane. It's really the difference between a little one-person workshop and a fully automated, massively parallel mega factory.
Okay, so with this brand new architecture, this agent swarm idea, how does Kimi K2.5 actually stack up against the reigning champs? You know, the big names like GPT-5.2 and Claude 4.5. Let's really look at the tail of the tape here.
The benchmarks, well, they tell a really fascinating story. When it comes to what we call agentic tasks, those really complex problems that need a lot of planning, using different tools, navigating the web, think about planning a multi-city trip from scratch or doing super deep market research. In those areas, Kimi 2.5 takes a decisive lead, no question. But for highly specialized, nitty-gritty coding, Claude 4.5 Opus is still wearing the crown.
I mean, its strength in these agentic tasks is just undeniable. Just look at this BrowseComp benchmark. This is a test that measures how well an AI can navigate and pull information from the web. And Kimi K2.5 doesn't just squeak by with a win, it clearly outperforms the competition. This really proves the raw power of that agent swarm architecture.
So here's the crucial takeaway. It's not a universal beats everything kind of winner. Well, not yet anyway. Its power is highly specialized. It absolutely excels in situations where teamwork, parallel processing, and using a bunch of tools are the most important thing. But for pure raw coding or some heavy-duty mathematical reasoning, yeah, the established giants, they still have an edge.
So what we have here is a specialized powerhouse that is seriously pushing the boundaries of what AI can do. It sounds incredible, right? A true breakthrough. But, and you knew there was a but coming, this is where we hit the reality check. Because all of that power, it comes at a very, very steep price.
And, as developers over on Hacker News, we're super quick to point out, this kind of revolutionary performance, it does not come cheap. Not at all. There is a massive, massive barrier to entry here. $500,000. Yep. That's the recommended hardware cost to run Kimi K2.5 effectively on your own servers. We're talking about a setup that needs 16 NVIDIA H100 GPUs. So yeah, this isn't a model you just download and fire up on your gaming PC. This is serious enterprise-grade data center level hardware. And wait, there's another catch. While you'll hear the term open source thrown around, it's actually more accurate to call it open weight. Now, what's the difference? Well, it means you get the finished model, the weights, but you do not get the training code. You don't get the data. You don't get the secret sauce they use to build it from scratch. So you can use it for sure, but you can't truly replicate it or build upon it in the same way.
And this quote from the discussion really hits the nail on the head. It raises a really serious question about accessibility in this whole AI space. I mean, is it really democratizing artificial intelligence if the price of admission to run it yourself is $500,000?
Okay, so let's put it all together. We've got this incredible power, these very specialized strengths, and this massive cost. So what's the big takeaway for you? Should you really be paying attention to Kimi K2.5?
Well, the answer really depends entirely on what you need it for. Look, for developers and researchers who are really pushing the boundaries of what agentic AI can do, yes, this is an absolute game changer, no doubt. But if your day-to-day work demands the absolute best, top-tier coding performance, then you should probably stick with Claude Opus for now. For most people, though, the smart move is probably just to use the API. That way you get access to all this power without the $500,000 hardware headache. But let's zoom out for a second, because the larger trend here is crystal clear. Powerful open-weight models, just like Kimi, are rapidly closing the gap on their closed-source competitors. And honestly, this is fantastic news for all of us. It just fuels more competition, it pushes more innovation, and it gives us all more choices in the AI landscape. It's a win-win.
And that leaves us with this final really important question. Kimi K2.5 proves that revolutionary performance can happen outside of the big closed labs. But it also forces us to ask, is the future of AI powerful open models for everyone? Or is it becoming an elite playground, just for those with $500,000 to spend? That's the real $500,000 question we're all going to have to answer. What do you think? Let me know your thoughts in the comments below, and if you got value out of this explainer, don't forget to hit that like button and subscribe for more deep dives into the future of AI.